Hello, my name is Mary. Today I am going to do my machine learning course assignment 1. I have created a GitHub repository so I can follow my code flow and my other homeworks in here. If I encounter some problems, I can roll back and discard changes and continue my assignment quickly. First of all, I don't like use Jupyter notebook, so I have installed PyCharm Professional. I have JetBrains license. Every student can have that. First of all, I use CachyOS, by the way. It's Arch-based Linux distro. It's not allowed to use pip library, Python library. So I have created a virtual environment for this homework. You can see there, and also you can see in here that's a virtual environment. Okay, let's dive in to our homework. I won't read every sentence in that page. We have important libraries like NumPy and Matplotlib, so that we can sketch our graph and other stuff. I don't know. Okay. In this here, first of all, we should import our libraries to use the other functions, the made-up functions in utils. I put some breakpoint so that I can see the code flow, so that I can see more properly and not just running the code, also I can debug the code. First of all, let's debug the first code. We don't need it, just importing. I will skip it, run. Okay. Server started at localhost. There's no problem. Let's load our data set, but we will debug it, debug the cell. As you can see, we reach the files in the data. Also, you can see in here, there's txt files open in Kate. There's some numbers, as you see in the last lecture, second lecture, I think. Some numbers, x and y, like input and output. As you can see, the other data here. Let's step over and see the x values. As you can see, 6, 5, 8. Also, you can see here the same data here and here. Okay, we will store in that variable, so we can use in our project. Okay, I won't debug everything, but you should see this before returning. Let's step over again, and y values 17, 9, 13. Also, you can see here. Okay, same values. We will import it from our data folder and x1 txt and x1 data1 txt file. Okay, let's continue the code. Yes, we load data returns to data set. I don't know, list maybe, another type of collection here. I don't know exactly what NumPy does, but it's a type of collection, I think. Okay, let's print our xtrain value. As you can see here, we did in the debug section and the y values. Okay, check the dimensions for variables. Okay, everybody can do that. There are 97 number of training examples. Okay. Also, we can visualize data with the PLT. As you remember, we imported in Matplotlib. Also, you don't have to use terminal to install the external packages. Also, you can create your own environment and just import the necessary packages. Okay, let's go. We will sketch some graphs in here. As you can see, there are some profit values, population of city with 10 case, okay, and there are some profit in 10,000 case. Profit versus population per city. There is some population, there is some profit. Okay, we have seen in our lecture, we know that what's in lecture 2, okay. Let's continue. Compute. We have seen in the lecture how can we compute the average value or compute cost. You know, extracting from actual value and the function value. As you can see, let's dive into first exercise. Okay, we didn't things just some. I think it's some log values. Okay, not important that. You know, execution count. Okay, now 3, 2, 1 because I have created a GitHub repository and copying the folder so that it's decreasing. Okay, if I executed, and it will increase that number. Okay, not important for us now. Okay, there are some exercise. First, we should compute cost below to iterate over training examples. The prediction model example, okay, as you can see, the cost is extracting and square it and divided by 2m. M is our size. Okay, number of. Okay. First of all, I will solve this problem for myself and stop recording. After that, when I solve it, I will continue to recording and explain this code. Okay. Okay, let's do it together. I don't want to write and read just read the code. We can do together this homework. First of all, calculate the predictions. Okay. First of all, calculate the total cost. Calculate the predictions. Okay. Predictions. As you can see, there's y times y times x plus b, and we should calculate the cost for each example. Example, and add to total cost. Okay. Total cost variable, as you can see, we did to return, and we created the variable and initialize with 0. Okay. Total cost equal to first open the parentheses 1 over Copilot can guess what should I write, so that I want to disable it. Okay. How can I? Whatever. 2m and NumPy feature with sum. Okay. Sum predictions minus y. Now, how can I say that? Power of 2. Okay. We calculated the total cost and return it. Okay. As you can see, there are some function definition. We can use everywhere this compute cost function. Okay. There is no error. We started the code. Okay. Compute cost with some initial values, parameters w and b. Okay. Initial w2, initial b1. Cost here we have write this function before. Xtrain as we seen in the first iTrain dataset. Initial w is here, initial b here. Okay. Compute cost we have already written. Okay. Print type cost. We're gonna we can see the type, and cost at initial zeros with point to have. I think it's limiting the floating size. Public test. Okay. Public test, we can import the public test is here, some test codes, and continue with the compute cost test. What is compute cost? Is here, compute cost function, okay, in the public test py file. Okay, let's compute. Okay, the cost all initial w is 75.203. Okay, expected output is true. Okay, now we did it. We succeed the code and succeed it. We can dive in again. Predictions. Okay, as you can see, calculate the cost for each example and add the total cost. Okay, 1 divided is here. 1 divided for 2m. M. What is m? Number of training examples, and sum it with prediction minus y, the actual value, and power of 2. Okay, it's correct. Now let's dive into the other exercise. I will stop the recording, and when I solve it I will continue. Okay, read it. Please compute the compute gradient function. We have seen in our lecture the gradient for parameters in an example. Return the total gradient example. Okay, here is m is number of training examples and sum with the summation operator. Okay, if there are some hints. Okay, I will stop recording and I will solve it and continue to record. Okay. Hello again. Let's dive into our code. We should start here. What we are gonna do first, for each example in the data set, we calculate the prediction using the model fwb function. Then we calculate the gradient for b and w by iterating over each example. Finally, we take the average of the gradients by dividing by number of the examples of m. Okay, let's start the code. First, we write for loop for I in range m. Okay, we iterate it. Let's write some explanation. Prediction for example I. Okay. F b equal to y times x I plus b. Okay. Then error for example I. Error for, let's put some here. Okay. Error for example I. Error equal to f w minus y. Y was I is our function, right? And calculate gradient for w and b. Okay, w b equal error times xi. Okay, and sorry, I misspelled it. dw. Okay, we initialize in here and we should do it in here. Okay, and increase with the error. And after the for loop, average the gradients. Okay, b divided equal m g b divided equal error. Okay, sorry, m. What was I doing? Okay, now we are good. And end of the function we should return this. Okay, let's define our function again. If there is some error, okay, no error again. And compute and display gradient with w initialized with zeros. Okay, where is the compute gradient test? We can look at is, I think, in public test py. Okay, we are using this function. As you can see, I uploaded in GitHub. Okay, now all tests passed. Okay, very good, very good. Now expected outputs true. Now test it again. Okay, values are true. We are very good. Okay, now the other example. Of course, I will stop. You will now find the optional parameters for linear regression by you. Okay, I will stop recording and do it again and continue the recording. Sorry, I wasn't reading. We don't do anything here. Just visualize the code flow. Okay. Now I will run this code. Sorry about late. Okay. Now let's run the grading algorithm about to learn parameters for our dataset. Dataset was here. Okay. Yes. Expected outputs are true, iteration and cost, as you can see. Okay. We will now use final parameters for linear fit. Are we do it right? We will see it. Okay. Now we will plot. Okay. Now very good. We can see the profit and population porosity. Okay. Your final value is WNP can also be used to make prediction on profit. Let's predict what profit will be areas 35k and 70k people. The model takes the population with 10k as input. Therefore, okay, we should write 3.5 and 7.0. Okay, predicted. Okay, no, it's true, right? Okay, that was great to visualize it by using, what was the library? The library name is matplotlib. It's a very good exercise to predict the population and profits per population. It's a very good example and writing some codes. We will, I submit the exercise 1 and also I will send it with exercise 2 so that if I do some mistake, I can roll back and solve it again. Okay, thank you for your time, and sorry about for late submissions.